We have not been to the moon in 53 years. That changes now. 53 years. That is how long it has been since a human being walked on the moon. Gene Cernan climbed back into his Apollo capsule in 1972, brushed lunar dust from his boots, and assumed we would be back within a decade. He was wrong. Tragically, catastrophically wrong. But right now, at this very moment, 4 astronauts are training for a mission that will take them farther from Earth than any human has ever travelled, and they are racing against a deadline that nobody wants to talk about openly. China has announced plans to land their own astronauts by 2030. America has less than 5 years to prove it can still lead in space. If you want to understand the most important space race of your lifetime, one that is happening right now while most people are not paying attention, make sure you are subscribed to this channel, because the stakes could not be higher. 53 years. That is how long humanity has been absent from the surface of the moon. The last human footprints left in the lunar dust belonged to Gene Cernan and Harrison Schmitt, 2 astronauts who climbed back into their tiny Apollo 17 capsule in December of 1972, never imagining that more than half a century would pass before anyone returned. And now, as we speak, a new chapter is being written. 4 astronauts are preparing to strap themselves into a spacecraft called Integrity. Engineers are running final tests on a rocket more powerful than anything that came before it. And somewhere in the Arizona desert, the first modules of a space station that will orbit the moon are being assembled piece by piece. But here is where the story gets complicated. The United States is not alone in this race. China has announced plans to land its own astronauts on the lunar surface by 2030. They are building a permanent base. They have already returned samples from the far side of the moon, something no other nation has ever accomplished. And the clock is ticking. Welcome to the most ambitious space race of the 21st century. Let me take you inside what is really happening right now. In a massive building at the Kennedy Space Center in Florida, a rocket stands waiting. It is called the Space Launch System, and sitting on top of it is a spacecraft named Orion. The crew who will fly this mission have already given it a name: Integrity. These 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen, are about to become the first humans to travel to the vicinity of the moon since the Apollo era. The mission is called Artemis 2, and if everything goes according to plan, they will launch no earlier than February 5th, 2026. Think about that for a second. For more than 5 decades, no human being has travelled beyond low Earth orbit. The International Space Station orbits just 400 kilometres above our heads. The moon is 384,000 kilometres away. That is nearly 1,000 times farther, and these 4 people are about to make that journey. The stacking of this rocket was completed in October of 2025. On October 18th, technicians at Kennedy Space Center used a massive crane to lift the Orion spacecraft and carefully lower it onto the top of the Space Launch System rocket. It was a moment that marked the end of years of preparation and the beginning of a countdown to history. But we'll get to the challenges facing this mission in a moment. First, you need to understand why this is happening now. The Artemis program was born out of a simple but powerful idea. Go back to the moon, but this time stay. This is not about planting flags and collecting a few rocks. This is about building infrastructure, creating a permanent human presence, using the moon as a stepping stone to Mars and beyond. Here is the deal. The program was officially established in 2019 under the first Trump administration. The goal at that time was absurdly ambitious: land astronauts on the moon by 2024. That deadline came and went. The reasons for the delay are numerous and interconnected, but they all point to one fundamental truth. Getting humans to the moon and back safely is extraordinarily difficult. The heat shield on the Orion capsule raised concerns after the Artemis 1 mission in late 2022. That uncrewed test flight went around the moon and back, but when Orion plunged through the Earth's atmosphere during re-entry, the heat shield ablated in ways that surprised engineers. Chunks of material came off. Investigation took time. Fixes had to be implemented. The life support system presented its own problems. Valves in the system designed to keep astronauts alive during the roughly 10-day journey needed to be redesigned. And then there is the spacesuit situation. Axiom Space, working in collaboration with the fashion house Prada, is designing the suits that astronauts will wear when they actually walk on the lunar surface during later missions. Those suits were not going to be ready in time for the original schedule, but despite all these obstacles, progress is being made. In the coming weeks, the Artemis II crew will participate in something called a countdown demonstration test. This is essentially a full dress rehearsal for launch day. The 4 astronauts will put on their Orion Crew Survival System spacesuits and walk to the rocket. They will be secured inside the spacecraft, simulating the final moments before liftoff. Every timeline, every procedure, every emergency protocol will be tested. Now, here is where things get really interesting. Artemis II is just a flyby mission. The astronauts will travel to the moon, loop around it, and come back to Earth. They will not land. They will not step onto the surface. That honour is reserved for Artemis III, and Artemis III is where the real drama unfolds. To land astronauts on the moon, you need a lander. NASA does not have one of its own. Instead, they contracted SpaceX to build it. The Human Landing System, or HLS, is a modified version of SpaceX's massive Starship rocket. At about 50 meters tall, it is roughly the same height as a 15-story building. An elevator will carry astronauts from the airlock down to the lunar surface. The problem is that Starship is not ready. SpaceX has completed 11 integrated test flights of Starship and its Super Heavy booster. Some of these flights achieved remarkable milestones. In October of 2024, SpaceX successfully caught a Super Heavy booster using the giant mechanical arms at their launch site in Texas. They call it Mechazilla. The booster descended from space, hovered over the launch pad, and was grabbed out of thin air by these massive chopstick-like arms. It was stunning to watch. But catching a booster is not the same as landing astronauts on the moon. There are capabilities that SpaceX has not yet demonstrated. Orbital propellant transfer is perhaps the most critical. To send Starship to the moon, it needs to be refueled in space. SpaceX estimates that the lunar lander variant will need to be refueled up to 12 times in orbit before it has enough propellant to make the journey. This has never been done. Not at this scale, not with these volumes of super cold cryogenic propellants. According to internal documents obtained by journalists, SpaceX's timeline shows a first uncrewed lunar landing attempt in June of 2027. That is right around when NASA had hoped to launch the Artemis III crew. If SpaceX's timeline holds, the earliest that astronauts could actually land on the moon would be September of 2028. That is more than a year past NASA's official target, and it gets more complicated. NASA Acting Administrator Sean Duffy has openly expressed concerns. In October of 2025, he appeared on financial news television and said in essence that SpaceX is behind. He announced that NASA was reopening the contract for Artemis III, inviting other companies to submit proposals for how they might accelerate the timeline. The implication was clear. If SpaceX cannot deliver, someone else might get the job. Enter Blue Origin. Jeff Bezos' space company has been working on its own lunar lander called Blue Moon. Blue Origin already holds a contract for the Artemis V mission, scheduled for around 2030. But they are moving fast. In November of 2025, Blue Origin achieved a major breakthrough. Their New Glenn rocket, a massive 321-foot tall launch vehicle, completed its second flight. This time, not only did the mission succeed in deploying NASA's twin Mars probes, but Blue Origin also recovered the first stage booster, landing it on a platform in the Atlantic Ocean. This was significant. Only SpaceX had previously demonstrated the ability to land orbital-class rockets. Now Blue Origin has joined that exclusive club. Blue Origin is now stacking the components of their first Blue Moon Mark I lander. This uncrewed cargo mission is planned to launch in early 2026. It will carry sensors and cameras to demonstrate the technologies needed for future crewed landings. The company has stated publicly that they could potentially accelerate their Blue Moon Mark II crewed lander to support the Artemis III mission if SpaceX cannot deliver. But wait. There is another player in this game that most people are not paying attention to. Commercial landers are already reaching the moon, right now, without waiting for Starship or Blue Moon. NASA's Commercial Lunar Payload Services program, known by its abbreviation, which is pronounced CLIPS, has been sending robotic landers to the lunar surface. This program represents a fundamental shift in how NASA does business. Instead of building and operating its own spacecraft, NASA pays private companies to deliver science instruments and technology demonstrations to the moon. In February of 2024, a company called Intuitive Machines became the first American entity to soft land on the moon since the Apollo era. Their lander, named Odysseus, touched down in the lunar South Pole region. The landing was rough. The spacecraft tipped over onto its side, but it worked. Data was collected. The mission was declared a success. Then came 2025. On January 15th of this year, 2 lunar missions launched together on a single SpaceX Falcon 9 rocket. One was Firefly Aerospace's Blue Ghost Mission 1. The other was the Japanese company Espace's Hakuto R Mission 2, carrying a lander named Resilience. Blue Ghost took the direct route to the moon and arrived first. On March 2nd, 2025, it touched down softly in a region called Mare Crisium, the Sea of Crises. This was the first fully successful vertical landing by a US spacecraft on the moon since 1972. Read that again. 53 years between successful American soft landings, and a company that most people have never heard of finally broke the streak. Blue Ghost carried multiple NASA instruments to study the lunar environment. It imaged a lunar sunrise. It observed the Earth as it crossed in front of the Sun, creating a total eclipse as seen from the moon. The mission operated through one complete lunar day, roughly 14 Earth days, before the brutal cold of lunar night claimed it. Meanwhile, Intuitive Machines launched their second mission, IM-2, on February 26th of 2025. Their lander Athena was heading to Mons Mouton, a high plateau near the lunar South Pole. The spacecraft carried a drill called Prime, one designed to search for water ice beneath the surface. But something went wrong. During the landing sequence on March 6th, the altimeter failed. A plume of lunar dust obscured the sensors. The lander struck the surface, tipped over, and skidded across the regolith, rolling once or twice before coming to rest inside a crater. The solar panels could not generate enough power. Within hours, the mission was effectively over. It gets worse. The Japanese company Ispace had taken a longer, more fuel-efficient trajectory to the moon. Their Resilience lander entered lunar orbit in May and attempted its landing on June 5th and 6th of 2025. The target was Mare Frigoris, the Sea of Cold, in the far northern reaches of the moon. Once again, disaster. An anomaly in the laser rangefinder prevented the spacecraft from determining its altitude accurately during the final descent. Resilience impacted the lunar surface instead of landing softly. Communication was lost. The mission ended. Now think about what this tells us. Landing on the moon is incredibly difficult. Only 5 nations have ever accomplished it. The Soviet Union was first, followed by the United States, then China, India, and Japan. But even among these spacefaring powers, failures are common. The graveyard of crashed probes scattered across the lunar surface is a testament to how unforgiving this destination is. And yet, despite these setbacks, the commercial lunar sector is not slowing down. More missions are planned. Astrobotic, another American company, is preparing its Griffin lander for a mission later this year. Firefly is working on Blue Ghost Mission 2, which will travel to the far side of the moon in 2026. Intuitive Machines has a third mission, IM-3, planned to visit a mysterious formation called Reiner Gamma, a lunar swirl associated with strange magnetic anomalies. The Draper Laboratory is building a lander that will touch down in Schrödinger Basin on the far side of the moon in 2026. This will be only the second time any spacecraft has landed on the far side, following China's Chang'e 4 mission in 2019. Now let us talk about China. Because while America struggles with delays and budget constraints, China has been executing a methodical campaign of lunar exploration that is startling in its ambition. Chang'e 5 returned samples from the moon's near side in 2020. Chang'e 6, which launched in May of 2024, went to the far side of the moon and brought back rocks from the South Pole Aitken Basin. This was a first. No other nation has ever returned samples from the lunar far side. Those rocks are some of the oldest material in the solar system, potentially revealing secrets about the moon's formation that have been hidden for billions of years. But China is not stopping there. Chang'e 7 is scheduled to launch in August of 2026. This mission will target the lunar South Pole with an orbiter, a lander, a rover, and something called a mini-hopping probe. This hopping robot will use rocket propulsion to jump into permanently shadowed craters where no sunlight ever reaches. Those dark, frigid pits might contain water ice. If they do, Chang'e 7 will find it. Chang'e 8 follows in 2029. This mission will test something extraordinary: in situ resource utilization. Chinese engineers have developed a device that can take lunar soil and, using concentrated solar energy, fuse it into bricks. They plan to demonstrate three-dimensional printing on the moon's surface. The goal is to prove that future astronauts can build structures using materials found on site, rather than hauling everything from Earth. These missions are the foundation for something much larger. The International Lunar Research Station. China has announced plans to build a permanent base at the lunar South Pole. The basic version is scheduled for completion by 2035. An expanded version would follow by 2045. This is not science fiction. This is the stated policy of the Chinese National Space Administration, and here is the part that keeps American officials up at night. China has announced that it intends to land astronauts on the moon before 2030. They are developing a new heavy lift rocket called the Long March 10. They are building a next-generation crewed spacecraft. They are testing lunar landers. Videos have emerged showing Chinese hardware undergoing touchdown and takeoff simulations. The pieces are coming together. If China lands astronauts on the moon before the United States returns, it will be perceived as a historic shift in the balance of space power. The symbolic victory would echo for generations. This is why NASA is pushing so hard to accelerate the Artemis program. This is why officials are openly considering alternatives to SpaceX. This is why billions of dollars are being poured into lunar infrastructure. Speaking of infrastructure, let us talk about the Lunar Gateway. This is humanity's first space station designed to orbit the moon. Unlike the International Space Station, which circles Earth at a relatively low altitude, Gateway will loop around the moon in a highly elliptical orbit. At its closest point, it will pass just 7,000 kilometers above the lunar surface. At its farthest, it will swing out to 70,000 kilometers deep into space beyond the moon. The first two modules of Gateway, the power and propulsion element, and the habitation and logistics outpost known as HALO, are being prepared for launch no later than December of 2027. In April of 2025, HALO arrived at Northrop Grumman's facility in Arizona after being fabricated by Thales Alenia Space in Italy. Engineers are now installing the propellant lines, electrical systems, radiators, and all the equipment that will make this module habitable. The power and propulsion element is taking shape at Maxar Space Systems in California. It will feature the most powerful solar electric propulsion system ever flown on a spacecraft. When Artemis 4 launches, likely around 2028, the crew will not only fly to the moon but also dock with Gateway for the first time. They will deliver an additional module, the International Habitation Module built by the European Space Agency with life support systems provided by Japan. This is truly an international effort. Canada is building an advanced robotic arm called Canadarm3. The United Arab Emirates is contributing a crew airlock. Partners from around the world have signed the Artemis Accords, agreeing to principles for peaceful lunar exploration. But let us return to the present moment. Right now, as you're listening to this, the Artemis 2 crew is training. They are reviewing procedures for every phase of their mission. They are practicing for scenarios that they hope will never happen but must be prepared for nonetheless. Loss of communication, system failures, medical emergencies. The spacecraft they will fly has been through years of testing. The heat shield issues from Artemis 1 have been addressed. The life support system has been upgraded. The Space Launch System rocket, for all the criticism it has received about cost and delays, remains the most powerful rocket ever built by NASA. When it launches, over 8 million pounds of thrust will push those 4 astronauts away from Earth. Their journey will last approximately 10 days. They will fly farther from Earth than any human has ever travelled, reaching a point about 4,600 miles beyond the moon before looping back. Along the way, they will test the spacecraft systems that must work flawlessly for later crews who will actually land on the surface, and then, if all goes well, they will re-enter Earth's atmosphere at speeds exceeding 25,000 miles per hour. The heat shield will have to work, the parachutes will have to deploy, they will splash down in the Pacific Ocean, where recovery teams will be waiting. This is not just a mission. This is a rehearsal for everything that comes after. The question that hangs over all of this is whether America can maintain its lead in the new space race. China is moving fast. They have demonstrated capabilities that the United States does not yet possess, including reliable lunar sample return and far-side operations. They are not constrained by the political fluctuations that have plagued American space policy for decades. At the same time, the commercial space sector in the United States represents an advantage that no other nation can match. SpaceX, Blue Origin, Firefly, Intuitive Machines, Astrobotic, Draper and others are innovating at a pace that government programs cannot. The commercial lunar payload services model is sending more spacecraft to the moon than at any time since the 1960s. Even if some of these missions fail, as they inevitably will, the cumulative effect is transformative. Each attempt generates data, each setback teaches lessons that are applied to the next mission. The cost of reaching the moon is dropping. The frequency of attempts is increasing. Former NASA Administrator Jim Bridenstine described this approach as taking many shots on goal. Not every shot will score, but if you take enough shots, you will eventually succeed. The next few years will be decisive. By 2028, we should know whether Starship can land astronauts on the moon. By 2030, we will know if China can make good on its promise to land their own crews. By 2035, we might see the first elements of permanent lunar bases from both superpowers. The moon is no longer a destination for occasional visits. It is becoming a workplace, a laboratory, perhaps eventually a home. And it all starts with 4 astronauts, a spacecraft named Integrity, and a launch window that opens in February of 2026. The return to the moon is not a future dream. It is happening right now. The question is whether you are paying attention, because the decisions being made today, the rockets being built, the landers being tested, the astronauts being trained, these will shape the future of human civilization in ways that we are only beginning to understand. We went to the moon once before. We left footprints and a flag. We collected rocks and took photographs, and then we stopped. This time, the plan is different. This time, we go back to stay. And that changes everything. The dawn of a new lunar age is upon us. The commercial companies are delivering payloads. The international partners are building modules. The astronauts are preparing for their journey. And somewhere in the shadows, a second space race is accelerating. This is the story of the return to the moon, and you are living through the beginning. But let me take you deeper into what is really at stake here. The lunar South Pole is not just another destination. It is the most valuable real estate in the inner solar system. Scientists believe that billions of years ago, comets and asteroids crashed into the moon, depositing water ice that has remained frozen in permanently shadowed craters ever since. These craters are among the coldest places in the entire solar system, with temperatures plunging below -200 degrees Celsius. Water on the moon is not just useful for drinking, it can be split into hydrogen and oxygen through electrolysis. Oxygen is obviously essential for breathing, but hydrogen and oxygen together make rocket fuel. If you can manufacture propellant on the moon instead of hauling it from Earth at enormous expense, you fundamentally change the economics of space exploration. This is why both the United States and China are targeting the South Pole for their bases. This is why the commercial landers are attempting to land in that region. This is why the Prime 1 drill on the Intuitive Machines mission was such an important payload. Finding water ice and characterizing its quantity and accessibility is perhaps the most important scientific question for lunar development. And it gets more intriguing. The lunar South Pole also offers another advantage. Certain elevated points along crater rims receive almost constant sunlight. These peaks of eternal light, as they are sometimes called, could host solar power stations that operate nearly around the clock. The moon rotates slowly, taking about 29 Earth days to complete one rotation. Most locations experience 2 weeks of daylight followed by 2 weeks of darkness, but these special elevated areas could provide continuous power. Imagine building a base on a mountain ridge that sees the sun most of the time, with shadowed craters containing water ice just kilometers away in the valleys below. You would have power and water and the raw materials to sustain human life indefinitely. This is not fantasy, this is engineering. Now let us examine what the astronauts themselves are doing to prepare. The Artemis 2 crew has been together for years now. Reed Wiseman is the commander. He flew on the International Space Station in 2014 and spent nearly 166 days in orbit. Victor Glover piloted the first operational SpaceX Crew Dragon mission to the station in 2020. Christina Koch holds the record for the longest single spaceflight by a woman, having spent 328 consecutive days on the station. Jeremy Hansen is a Canadian fighter pilot and engineer who has been training for space missions for over a decade. These 4 individuals have been through thousands of hours of preparation. They have practiced in simulators that replicate every phase of their mission. They have trained for spacewalks, even though Artemis 2 does not include any, because astronauts must be prepared for contingencies. They have studied the Orion spacecraft systems until they know them as intimately as they know their own bodies. In August of 2025, the crew participated in familiarization activities at Kennedy Space Center. They walked on the crew access arm of the mobile launcher, the pathway they will take from the tower to the spacecraft on launch day. They have been photographed in their orange flight suits, helmets under their arms, walking toward their future. But here is something most people do not realize. The Artemis 2 mission is carrying science payloads beyond just the human passengers. 5 small satellites called CubeSats from international partners will be deployed during the mission. Germany is sending a satellite called Tacheles that will examine how space conditions affect electrical components used in lunar vehicles. Argentina is contributing a satellite called Atenea that will study radiation shielding and map the space radiation environment. South Korea and Saudi Arabia are also providing CubeSats. These tiny spacecraft will separate from Orion and begin their own scientific investigations while the crew continues toward the moon. This is the Artemis Accords in action. The agreement that NASA negotiated with partner nations establishes principles for peaceful lunar exploration. It covers issues like transparency in space activities, the registration of space objects, sharing scientific data, protecting heritage sites like the Apollo landing locations, and extracting resources from celestial bodies. As of early 2025, over 40 nations had signed the Artemis Accords. They include traditional American allies like Japan, Canada, the United Kingdom, France, Germany, and Australia. But they also include countries like India, Israel, the United Arab Emirates, and Brazil. The coalition is growing. China and Russia have not signed the accords. Instead, they are building their own international partnership around the International Lunar Research Station. Russia's space agency Roscosmos is collaborating with China, though Russia's contributions have been limited by economic sanctions and budget constraints. Other nations, including Pakistan, Venezuela, and several African countries, have expressed interest in joining the Chinese-led initiative. The moon is becoming a geopolitical battleground. Some analysts have compared the current situation to the scramble for territory in previous centuries. Others prefer to see it as a new era of cooperation and discovery. The truth is probably somewhere in between. Competition and cooperation often coexist in complex ways. Let me take you inside the rocket factories for a moment. At the Michoud Assembly Facility in New Orleans, technicians are welding together the core stages for future Space Launch System rockets. The core stage of the SLS is over 200 feet tall and contains the massive propellant tanks that hold liquid hydrogen and liquid oxygen. 4 RS-25 engines, based on the engines that powered the Space Shuttle, provide over 2 million pounds of thrust. At SpaceX's Starbase facility in Boca Chica, Texas, the production of Starship vehicles continues at a remarkable pace. Massive stainless steel rings are welded together to form the ship's cylindrical body. Raptor engines, which burn methane and oxygen, are tested on stands that shake the ground for miles around. The factory operates around the clock. At Blue Origin's headquarters in Kent, Washington, and their facilities in Florida, engineers are building the BE-7 engines that will power the Blue Moon lander. Unlike the methane-burning Raptor, the B-7 uses hydrogen and oxygen, fuels that can theoretically be produced on the moon itself. The infrastructure supporting this return to the moon is vast. Launch pads at Kennedy Space Center and Cape Canaveral have been upgraded. The historic launch complex 39B, from which Apollo missions once departed, has been modified for the Space Launch System. Deep space communication networks have been enhanced to maintain contact with spacecraft thousands of miles from Earth, and the science community is preparing for what these missions will reveal. Geologists are eager to study the ancient impact basins of the lunar South Pole. The South Pole Aitken Basin is the largest and oldest recognised impact structure on the Moon, possibly in the entire solar system. It spans roughly 2,500 kilometres and reaches depths of over 8 kilometres. The violence of the impact that created it would have excavated material from deep within the Moon's interior, material that could tell us about the Moon's composition and formation in ways surface rocks cannot. Astronomers want to place telescopes on the far side of the Moon, shielded from the radio noise of Earth. The far side is the quietest place in the inner solar system for radio astronomy. From there, telescopes could detect faint signals from the cosmic dark ages, the epoch before the first stars formed. Firefly's Blue Ghost mission, 2, planned for 2026, will carry a prototype radio telescope to the lunar far side as a first step toward this goal. Biologists are interested in how lunar conditions affect living organisms. The Euglena company contributed a payload to the space mission that would have tested food production using algae. Though that mission failed, future landers will continue these experiments. Learning to grow food on the Moon is essential for any long-duration presence. Material scientists want to study lunar regolith, the layer of broken rock and dust that covers the surface. This material has unique properties because it has been bombarded by micrometeorites and solar radiation for billions of years. Understanding how to work with regolith, to extract water or metals from it, to use it for construction, is fundamental to lunar development. The next few years will be busy. In 2026, expect to see the Artemis 2 mission fly around the Moon. China's Chang'e 7 will attempt to land at the South Pole with its hopping probe. The Draper mission will touch down on the far side. Blue Ghost mission 2 will head to the far side as well. ISpace is planning its mission 3, learning from the failures of mission 2. In 2027, the Gateway modules should launch. SpaceX hopes to demonstrate orbital propellant transfer. Blue Origin may attempt its first crewed Blue Moon flight. In 2028, Artemis 3, or perhaps Artemis 4, could finally land astronauts on the surface. Gateway should be operational in lunar orbit. By 2029, Chang'e 8 will be testing three-dimensional printing on the Moon. Both superpowers will be racing toward permanent bases, and by 2030, one of them will likely have astronauts living and working on the lunar surface. This is not speculation. This is the publicly stated timeline of the space agencies involved. There will be delays, there will be setbacks, rockets will fail, missions will be lost, but the trajectory is clear. Humanity is going back to the Moon. The question that should occupy every thinking person is what this means for our species. Are we entering an era of expanded human presence across the solar system? Will the Moon become a platform for reaching Mars and the asteroids? Will we look back on this decade as the moment when Earth-bound civilization became a spacefaring civilization? Or will this be another false start, another burst of enthusiasm that fades when budgets tighten and attention wanders? History offers cautionary examples. After Apollo, we retreated to low Earth orbit for half a century. The Soviet Union collapsed before it could realize its own lunar ambitions. Numerous commercial space ventures have promised revolutions that never materialized. But history also offers hope. The International Space Station, for all its expense, has hosted continuous human presence in orbit for over 2 decades. SpaceX proved that reusable rockets were possible when many said they were not. Commercial crew transportation to orbit is now routine. The difference this time may be that multiple actors are pursuing lunar goals simultaneously. If NASA falters, China will continue. If SpaceX delays, Blue Origin and other companies will step forward. The commercial sector is not dependent on a single government's priorities. The international coalition is broader than ever. The Moon is waiting. It has been waiting for 53 years. And finally, we are going back. The astronauts know this. They feel the weight of history on their shoulders. When Christina Koch looks at the Moon, she knows she may be one of the first people to walk on its surface in the 21st century. When Victor Glover reviews mission plans, he understands that millions of people around the world will be watching. When Reed Wiseman commands the Integrity spacecraft, he carries the legacy of every astronaut and cosmonaut who came before. This is their moment. This is our moment. The return to the moon is real. The rockets are built, the spacecraft are tested, the astronauts are ready. All that remains is the countdown, and that countdown has already begun.